Hey guys, welcome back to another tutorial. Today's tutorial is going to be part number 8 in my Making Snake and Ncurses tutorial series. And today's tutorial we're actually going to be animating the snake using the queue data structure. And in the first half of the tutorial I'm going to be showing you guys how we're going to use the queue to animate the snake. And in the second half I'm actually going to be coding it up. If you haven't seen the previous 7 parts in this tutorial series, I recommend going to check those out first. And if you haven't seen my other tutorial series on Ncurses, that's probably good to start with. If you don't know anything about Ncurses already, you're going to want to start there. Otherwise, if you guys like this video, consider giving it a thumbs up. If you want to see more stuff like this, consider subscribing. If you have any questions, leave them down below. I try to answer pretty quickly. And otherwise, let's get started. So in order to explain how we're going to be using a queue data structure in order to animate our snake, I've put together a little graphic here. This is going to help me kind of walk through the steps, and we're going to detail kind of each step in the process of animating the snake for the various different states our snake can be in. Now in this case there's actually only 2 states that our snake can be in during the game. There's the initialization state, which kind of happens before the game starts. It happens at the very beginning of the game. It's basically just when we build the snake, we add its pieces to the board, and then we're basically just getting set up before the game actually starts. And we'll place the first apple. So technically this apple wouldn't be here until the end of the initialization stage, but I'm just putting it there now for illustration purposes. All right, so what we have here basically is over here on the left we have this basically represents a queue. It goes on forever. I just stopped at 9 because during this demonstration I won't be using more than 9 pieces. But this basically represents a queue, the queue in memory that we're going to be using. These here are going to be snake pieces. I've gone ahead and created a few just to save some time, but we're going to be building and creating the snake using snake pieces. And then over here is our imaginary board, just a 10 by 10 board. Our actual game board is going to be bigger, but just for demonstration, here we go. And then over here I've just wrote down some helpful steps that we're going to use for each of the states. Alright, so let's just get started. So essentially the first step is the initialization stage, or state. Now during the initialization state, like I said, this is when we actually build the snake and add its pieces to the board. This happens behind the scenes basically so fast that the player can't even see it. But I'm going to walk through it slowly here so that we can kind of understand how the queue works and how the initialization stage works. So essentially there are 3 steps in the initialization stage. First, for each piece, for each part of the snake, we need to create a snake piece. So right here, snake piece A is going to be my first snake piece. The A, the B, C, and D, that's not actually part of the data structure. That's just a helpful way for me to identify these pieces and talk about them. So our first snake piece is going to be snake piece A. So let's just say we create this snake piece and we're going to assign it a location. So I'm going to have the first snake piece be at position 1, 1 right here. So I'm going to assign it its location here. So 1, 1. And remember, we're going to do Y and then X. In this case, it doesn't matter because they're the same. But so we create that piece, then we draw it on the board. That's step 2. So I'm going to draw it by just putting A there, so we know this is snake piece A. In the game, it would look like that, but just for demonstration, and so that we know what piece is where, I'm going to put the letter of that snake piece in the board. So we draw it there, and then we add the snake piece to the queue. So when we add it to the queue, there's no other items in the queue yet, so it gets added to the front. This is the front of the queue, by the way, position 0. Alright, and then we repeat this for the next 3 pieces, because my snake is going to start out with 4 pieces. You could start yours with 5, 6, 7, whatever you like. I'm going to have mine start with 4. So the next piece I'm going to put at position 2, 1. So, technically we'd create the snake piece, but it already exists. Assign it its location to 1. Draw it on the board, and then add it to the queue. So I'm going to put it over here in the queue like that. Then snake piece C, I'm going to put that at position 3, 1. So 3, 1, we assign its position. We then perform the draw. So we draw snake piece C at position 3, 1, and then we add it to the queue. And then finally snake piece D, I'm going to put that at position 3, 2. and draw it on the board, and then we add it to the queue here. All right, so technically at this stage we would perform a refresh, and then the board would actually show these things all on the board. Right now there's no refreshing or whatever. This is just a demonstration. So, all right, so now we're on to the main step, or the main state, which is a little bit different than the initialization state, because instead of drawing all the pieces, we're just moving one piece per turn, basically. So the way the main state works is we start out by saying, okay, what is the next head? So like, what's the next position that our snake is going to need to move into? So right now I'm going to say direction's actually right. So this is the direction of the snake. I'm going to say that D is the head. So the head is always the last item that was added to the queue, kind of counterintuitively. So the head is always the last item. The tail is always the first item in the queue. So the head is D here, and if we're moving right, then the next position is this position here. So here's a helpful table down here. If you're basically given a direction, you take the current head, so current head is D, and you take its row and you add 1 to the column in the case of right. So what we're going to do here, so we get the current head plus its direction, plus the direction of the snake, and we find out that the next open spot is position 3, 3 here. Because, we're moving right, that means we take the row of the current head, so row is 3, and then we add 1 to the column, so that also gives us 3. So this is the position of the new snake piece. So we know this is the new position, then we say, okay, if that position there is blank, which it is in this case, we want to pop the head of the snake, or head of the queue out. So we're going to pop off this first item, and then I'm going to move these items up, which just happens automatically. But because I'm doing this in a demonstration, I have to do it manually. But so yeah, we pop the top item off because the next location is blank, and because it's blank, we also take its previous position, so 1, 1, and make that blank on the board. So that is gone now. And technically, in my implementation of the snake game, we're just going to discard that piece. We're not going to reuse this piece. So let's just say we discarded A, and this is now a new piece called E. So I'm just going to reuse the block to make it easier. And so that won't have any position there. So we discarded that piece because we no longer need it. And then, okay, so we've added a blank at the previous, the position that basically snake piece A, we added a blank there. And then we created this new snake piece, and we assign it the coordinates, which are the next head location. So that's 3, 3. And then we draw that snake piece, so E, and then we add it to the queue, like so. All right, so that repeats the next turn. So again, we look at the head here. The head of the snake here has position 3, 3. And we're moving right, so we know that the next snake piece is going to have the same row and then the column plus 1. So it's going to be 3, 4. So that's here. Looking at it, obviously, we know where it is, but mathematically, that's how you figure out where the next position is. So because that's a blank piece, we want to pop the top item off the queue, and then, again, just move these up, which would happen automatically, like that. And again, we're just going to discard this snake piece because that's just how the implementation works. And this is going to be now snake piece F. A, B, C, D, E, F. Yeah, just make sure I know my alphabet, geez. All right. And we know the new position for this is going to be 3, 4. So then we draw that on the board. That's the next step, F. Oh, sorry, we also need to draw, we skipped a step in step 2. We need to draw a blank where B was, because that's no longer exists. So now we created F, and we draw it on the board, and then we add it to the queue, like so. So I'm going to stop here and just kind of explain why we're using the queue as opposed to just having like an array that we iterate over. So if we had an array that we iterated over, every single time we would be redrawing all of these characters. Whereas when we use the queue, we're only redrawing 2 characters because the end piece is getting deleted and the head piece is getting added. So that's why it's a little bit more efficient to use the queue, and we don't have to really keep track of anything. At any given time, we're only changing 2 cells, which is just, it's easier to manage, and you're not accidentally going to delete things. You don't have to touch pieces that aren't moving. A lot of reasons, but so that's why the queue makes a lot of sense, and it works out in our case for what we're doing. All right, so in the next step, in this state, it's going to be a little different because we have an apple here. So what happens when the snake eats the apple? When a snake eats the apple, it adds a piece to the snake. So how are we going to do that given our current state? So that's where this if statement comes into play. That's why we added this if statement. Before, it might have seemed like, why do you have an if statement? But the if statement basically takes into account if for some reason there's an apple there. So in this case, we still get the next location for the head. So again, because we're moving right, we take the current head, we take its row, 3, and then we add 1 to its column. So we make that 5. So 3, 5 here. And because the next location isn't blank, we're not going to pop C off the queue here. We're going to leave it in the queue. We are going to create a new snake piece though, so I'm going to just copy and paste one of these guys like that. And it's going to be snake piece G, E, F, G, yeah. And then we're going to give it its new location, so 3, 5, which we got earlier. Now we're going to replace this with the new snake piece, so we're going to draw G there, and then we're going to add it back to the queue. So in this case, we didn't blank out C, we didn't remove C from the queue because we didn't need to, because essentially this time, instead of just moving our 4 pieces ahead, we're technically adding 1 piece to the snake. So we don't want to remove 1, and we don't want to remove it from the board. So that handles that case there, and then technically, hold on, Control Z. Technically, I gotta move this to a different cell, so I don't know, I'll move it to a random position down here, and then put G there. Do all this again, put it back in here, blah, blah, blah. Yeah, so technically the apple would move to a different spot automatically at that point. But that's something we'll handle later, obviously. But I hope this kind of helps explain how we're going to be using the queue to animate the snake. And we're going to be following pretty closely. We're going to be following these steps pretty closely in the code. Not exactly, but these are pretty much the general steps we're going to be following in the code. So this is almost like pseudocode that I wrote here. And in the next phase of this tutorial, we're going to actually animate the snake. So see you in a sec with that. So now that I've explained how we're going to actually animate the snake conceptually, now we can go into actually coding the snake animation. So first step, we're going to make some changes to snake.hpp, which we worked on in the last tutorial. There's a few things I have to fix actually from the last tutorial. In particular, I accidentally swapped where the tail and the head is. Currently I have it saying that the tail is at the back of the queue, when in reality the tail is actually the front of the queue, which is kind of counterintuitive, but that's just how the snake moves along. The tail is actually the front of the queue and the head is actually the back of the queue. So that's all fixed now. I'm going to remove these to-do statements here. So just make sure you swap those in your code as well. And we have to add a couple functions just to make things easier. The first 2 functions we're going to add are pretty straightforward. Get direction and set direction. They're just going to allow us to get and set the snake's direction. So first one, get direction, is going to return a direction. Get direction, return cur direction, like that. Then set direction is going to return void because we're just setting something. And it's going to take a direction as a parameter. And we're just going to set cur direction equal to D, like that. So those are out of the way. Now next head. So next head is the step in the conceptual diagram I was using where we take the current head and decide what the position of the next head is going to be. That's what this next head function is going to do for us. So it's going to take, it's using the current position of the head of the snake, it's going to figure out what the next head should be. Or I guess technically it's the current position plus the current direction. So it's going to return, we're going to have it return a snake piece because it's going to return a piece with the coordinates of the next head. So it's going to return snake piece. It's going to be called next head, like that. It's not going to take any parameters. So from the start, the first thing we need to do is get the current coordinates of the current head. So we're going to say int row for the row of the current head, and say equals to head function. So we're calling this head function here, and dot get x, like that. And then we're going to do the same thing for the column, equals to head get y. Oops, sorry, I screwed those up. This is actually y, that's actually x, like that. So now that we have the current position, the row and column of the head, we can do a switch statement on the current direction. So direction, current direction, like that, and we're going to check to see what the current direction is. And based off of that table that I showed in the conceptual diagram of the snake being animated, we're going to have a case for down. So in the case that the current direction is down, add a break statement. So if it's down, we want to add 1 to the row. So we're going to do row plus plus, like that. If the direction is up, we're going to do the opposite. We're going to do row minus minus, break. Then in the case that we have the direction pointing left, we're going to, left would be call minus minus, like that, break statement. And in the case of right, we're going to do the opposite, call plus plus. So break. And then there shouldn't be any other options, so we don't need to do a default statement or any other case statements. Direction can only be down, up, left, or right. So those are the only options we have. So this will accurately update the head position to wherever it should be, and then we're going to return a snake piece with the updated row and column, like that. So with next head out of the way, we're actually all done in the snake.hpp file here. We're going to move on to making some changes in snake game. So right off the bat, I did a couple things just to save some time. I added in this include statement for snake.hpp because we're going to need to include the snake so we can actually use it in the code. So I added that, and then I moved the variables from down at the bottom up to the top here just to make it a little easier. Then the steps underneath this board step within the constructor, I actually moved to their own function called initialize. So I just moved these three lines, which were in the constructor, into this initialize function. You're going to want to go ahead and do that. And then I think that's it for changes in this file. So now we can get started adding stuff here. So the first step is we actually have to add the snake class to, we have to add what's it called? A member variable snake to this class, so that way we can actually reference snake here. And then down in the initialize function, we're going to actually do the initialization steps that we talked about in the conceptualization. So now that we have our snake class initialized, we can actually, or snake class added, we can actually initialize it down here. So the first thing we're going to do, the snake class doesn't take any parameters, so it's already set up. The way we're going to initialize the snake is a little different than the way we talked about it, but you'll see what I think you'll understand what we're doing here. So the first thing we're going to do is we're going to create a new snake piece. We're going to call it, actually first thing we want to do is we want to set the direction of the snake, because right now the snake doesn't have a direction. I think by default it does have a direction actually, but I want to make sure it's going the correct direction. Yeah, default it's down. I'm going to make the direction of the snake right, and you'll see why in a minute. So we're going to do snake.setDirection, and then we're going to set it to right, like that. So, and the next thing we're going to do is we're going to create a snake piece, kind of like in the steps, the initialization steps. We're going to make a snake piece at position 1, 1. So we'll call this snake piece next, and it'll be equal to snake piece 1, 1, kind of like we did in our example. Now what we're going to do is we're going to draw the snake piece. So we're going to do board.add next, and then we're going to add it to our snake. So snake.add piece. So this first part is just like the initialization steps in our conceptualization. The next steps are going to be a little bit different. So what we can do now that we've added a snake piece to our snake is we can generate the other pieces using this next head option. So that's why I set the direction to down, because we're actually going to create the same exact layout as we did in the conceptualization, where we have 1 at 1, 1, 2, 1, or sorry, 1, 1, yeah, 1, 1, 2, 1, 3, 1, and 3, 2. So the way we're going to do that is, now that our direction is set to, actually, we want to set our direction to down to start with. Now that our direction is set to down, and we actually add that piece like that. Now that our direction is set to down, what we can actually do is set next equal to snake.nextHead, like that. What this is going to do is it's actually going to calculate for us. It's going to spit back out, all right, because the current head is at 1, 1. It's going to calculate using next head that we need to basically add one to the row and put us at 2, 1. So it's going to give us the next piece. We add it to the board, so we're drawing it basically. That's what this step is. And then we actually add it to the queue, like that, next. All right, so we're actually going to repeat the same step twice because that gives us 1, 1, 2, 1, and 3, 1. And then for the last step, we're just going to change the direction of the snake. So we're going to say snake.setDirection equal to right. And what this will do is it'll give us that last piece at 3, 2, because now the snake's moving right, so it's going to add 1 to the column instead of adding 1 to the row. So we'll do, again, we can just copy this step up here, like that. Now this should give us our snake. So what I'm going to do now, now that we've done that part of now that we've handled the initialization state, we can actually move down to the main state steps. So I'm actually just going to delete most of what's down here right now. I'll save that bit, but we can get rid of this part. Yeah, and we're just going to reorder the rest of this stuff. So the first part of the main game loop that I actually technically skipped when we were doing the conceptualization is we need to check to see if there's already an apple on the board, and if there isn't, we need to add one. So the way to check to see if there's already an apple on the board is to just check to see if our apple variable is null, because if it's null, that means there's no longer an apple, and we need to create one. So the way we're going to do that is, let me just make this if statement a multi-line if statement like that. So instead of checking if apple is not equal to null, we're going to check if apple is equal to null. And if it is equal to null, we're going to want to get the just a set of random empty coordinates from the board. That's what this function does. We went over this in a different tutorial. So we're going to get a set of random empty coordinates. We're going to create a new apple with those coordinates. So we're basically creating an apple because there wasn't one. So we'll create a new apple with those coordinates, and then we're just going to add the apple to the board. So what this is going to do is add the apple to the board if it doesn't already exist. So this is an important step because later on maybe we eat the apple, it disappears, and we need to remember to re-add it to the board at the beginning of the next step. All right, so now we can actually handle the animation of the snake. So if we think about the steps from before, the first thing we do is we get the position of the next, what the position of the next head is supposed to be. So we're going to do kind of like we did in the initialization step. We're going to create a snake piece called next, and we're going to have it be equal to snake.nextHead. And then what we're going to do is, now this is the step where we check to see if the piece is on the blank, the next piece would be on a blank spot, or if it's on a spot where there's an apple. So the way we're going to do that is we're going to use an if statement and say, whoops, accidentally opened up my Steam library, my bad. We're going to, so what we're going to do next is we're going to say if next.getX equals apple get x, and actually we're checking to see if it's a blank spot. So we want to check if apple is not equal to, if the apple's x is not equal to the next position's x, and if next.getY is not equal to apple, oops, can't spell today, apple get y, like that. So in this scenario, what we want to do, so if it's a blank spot, which is what this is checking for, right? We're checking to see if the next head is not on the apple, which if it's not on the apple, it's a blank spot. And until we get to when later on we'll have to handle collisions, that'll be a separate thing. But for right now, we're just going to assume if it's not on the apple, that it's a blank spot. So what we do in that case is we're going to get the row and the column of the current tail. So we're going to say row, or I say empty row equal to the tail of the snake. So snake.tail.get y, and then we're gonna same thing for empty call. So snake tail.get x, like that. So now that we've gotten the row and the column, we can insert an empty spot where the tail was. So let's say board.add empty row, empty call, like that. So that's just gonna basically, it's gonna empty out that spot where the tail is, because at this point the tail is moving forwards. So once we've emptied that location, we can actually remove the tail from the snake, and we no longer need it. It just gets discarded, basically. Garbage collection will clean it up, and it essentially just doesn't exist anymore. So after we've done that, we're going to take that next snake piece and we're going to add it to the board. So board.add next, like so. And then we're going to add that next piece to the snake as well. So snake add piece next. All right, so this is actually all we need to implement the main state, at least for the current standards that we're going to hold it to. There's going to be more stuff we'll add down the line, but this is the basic animation of the snake. So there's a couple other things I want to do just so I can demonstrate this to you over here. So the first thing we need to do is add a timeout to our board. So that way, basically right now I think I can't remember if it just waits forever for input. Yeah, looks like it just waits forever for input. So I'm going to add a timeout so that every second it'll refresh the screen, essentially. So what we're going to do is we're in the board.hpp function down in the construct, or board.hpp file down in the construct function. And we're going to make a call to wTimeout, and we're going to set it to equal to 1,000 milliseconds, so 1 second. So this is going to mean basically the board is going to refresh every second, and if I press a key, it'll actually refresh faster. But this means if no keys are pressed, every second the screen will refresh. And then one other thing I'm going to do, just because I get a little annoyed so the cursor shows up right now during the animation, I want to turn the cursor off. So the way you do that is you use a function called curseSet, and we're going to set it equal to 0. This is just going to hide the cursor so it doesn't show up on the screen every time we draw. But all right, with all that done, hopefully I can do a make right now. Oh, there's an error. wTimeout. I forgot to pass it the window, so that would be board when, like that. All right, so now we should be able to make, and run, and you'll see that, segmentation fault. What did we do? So let's see, in snake game, I know what we need to do. So what we need to do is we need to set the apple equal to null at the beginning. So apple equals null. I believe. I'm pretty sure that's what's wrong. So we'll do clear, make, and run. Yeah, all right. So now, as you can see, the snake is animating. It's moving along the screen. It placed the apple in a random location. And now, just to kind of show you what that wTimeout is doing, if I go to board again and change the wTimeout to, we'll say 100 milliseconds, the animation will run faster. So as you can see, it runs a lot faster now. So we're not going to use 1 second when we actually do the game in the future, but just for now, 1 second's good so that we can kind of see things as they're happening, and everything doesn't move away too quickly. But all right, yeah, so that is animating the snake. This is probably going to be a pretty long tutorial, but I hope you guys liked it, and if you did, consider liking, subscribing, commenting down below, and hopefully I'll have the next one out soon.